Good morning. The Automated Log Tagging and Tracking project is part of the Automation and Robotics PGP program, which is managed by Forest Growers Research. The project started last year and is expected to be completed by the end of 2025. This morning, I will give you some background to and a brief progress report on the project. For some parts of the world, the question is, why tag logs? This question doesn't apply to New Zealand. More than 60% of the roundwood produced in New Zealand is exported as logs, and these logs are all scaled and paper tagged at inland or marine ports before they leave the country. The question for us is, where should we tag the logs? This project is about tagging in forest so that the benefits can be obtained earlier. I don't have time this morning other than to highlight a few of the benefits of tagging and tracking. These include improved health and safety, forest to mill supply chain efficiencies, improvements in mill recovery and profitability, improved handling and control at ports, traceability and chain of custody, and an opportunity to target genetics and nutrition by site and aspect. Between 2000 and 2010, the Europeans carried out a very large project called the Indisputable Key Project. It looked at a wide range of potential tagging technologies, from paper tags to biometric fingerprinting to DNA analysis. Here are the top three contenders. One was radio frequency ID tags. They got to the stage of building a prototype on a harvesting machine. A tag from a canister was punched into the end of the log. Problems with consistent tag readability and with costs were issues with this technology. Another top contender was inkjet printing of logs. The Woodland system is a commercial solution today. A stand ID, but not a log ID, is sprayed onto the log end. The Indisputable Key project earlier tried spraying a QR code on the log end through holes in the chainsaw bar, but this didn't go any further. The third contender was a punch code system. It is a refinement on a technology that is at least 200 years old called branding hammers, except that the symbols can be changed for every log. A solution about the size of a credit card is under development. Let's take a sidestep for a minute and look at the cost of tagging. Let's assume that a tag costs 10 cents per marked log. The cost per cubic metre will obviously depend on how big the log is. Long fat logs would cost 10 cents per cubic metre. Short skinny logs would cost close to $2 per cubic metre. Now let's look at the cost of the different tagging solutions for a 200mm small end diameter log that is 3.6 meters long. Passive RFID tags, bought in bulk, may cost 30 cents each. That equates to $2.25 per cubic metre. In comparison, inkjet tagging costs about 2 cents per tag, or about 15 cents per cubic metre. And punch code tagging has a nominal cost of about 0.4 of a cent per tag, or about 3 cents per cubic metre. I'm sure you are not surprised that the technical steering team for the Robotics and Automation program recommended that FGR proceed with the development of the punch code system. Comparatively low cost, no consumables, and extremely large numbers of logs that can be uniquely tagged are features of this system. With this 12-symbol, 16-position code on the left of your screen, we can uniquely tag over 280 trillion logs. Otmetka, a Swedish company, own the IP for this technology. The objectives of the Automated Log Tagging and Tracking project are to design, develop, manufacture and commercialise an automated log tagging, tag reading and log data storage system. Implementation of the tagging solution will be carried out on an in-forest grapple processor and at a central processing yard. If the project is to be successful, it will have to satisfy the tracking needs of participants right across the forest to log customer supply chain. It will have to operate effectively in harvesting operations and trucking operations, in satellite yards, in marine ports and mill yards. The goal is to design and manufacture tag applicators and fixed and mobile tag readers. As part of the system, we will also be developing blockchain data storage and management capability. Testing of the system will be carried out in harvesting operations, a satellite yard, a mill yard, and at a port. So what progress have we made? COVID-19 has certainly pushed our timeline backwards by several months. However, a work plan and budget have been prepared, and the project team has been established. We have 5 forest companies so far committed to the project. 3 of these are integrated companies with mill operations. We have the 2 biggest port logistics companies in the team. We have a grapple processor manufacturer on the team, plus a company that will develop the tag reading equipment. Importantly, Otmetka has also established a subsidiary here in New Zealand and will be participating in the project. Our goal is to have developed and built and tested both alpha and beta prototype versions of the applicators and the readers by the end of 2022. There are some provisos to our goal, of course. The first proviso is that the proof of concept must be successfully completed for both applying the tag and being able to accurately read the tag. The second proviso is that the concept must be economically feasible. The benefits of tagging early in the supply chain must outweigh the costs. 2 sets of testing have shown that a code can be generated, passed to mechanical equipment and applied to a log end. One of the demonstrations was with technology that could be fitted to a harvesting machine. The other was with a simple but automated hammer. Another proof of concept test showed that computer vision could be used to find the punch code symbols on a log end and convert them to an ID code. This test completed the tag generation, tag application, and tag reading circle. The next short video clip shows the code being passed to the mechanical equipment and the code being stamped onto a log end. On the left-hand side, you will see the code symbols rotating to the new generated log ID. The Swedish proof of concept tests were carried out under laboratory conditions. The New Zealand proof of concept trials are being carried out under a wider range of conditions that are likely to be encountered in New Zealand. We want to determine the effect on readability of log-end conditions, time since application of the tag, treatments such as anti-sat stain treatment, lighting conditions, distance from the camera to the log end, angle of the camera to the log end, weather conditions, and species. The tests will allow us to determine under what conditions reading works best, how much gain in readability can be gained with improvements in different hardware and software, and what changes might be needed to work methods to optimize its performance. The first steps in determining the economic feasibility of tagging with the punch code system has been for our stakeholders in the project, that is the forest owners and port logistics companies, to map the forest to customer supply chain and to mark where in the supply chain they would read a tag if one was on a log. The supply chain is complex and there are many locations and activities where tag reading could take place. For example, stakeholders identified 4 places in a transfer yard where tag reading could take place. The different coloured eyes represent different stakeholders. The next steps will be to attach costs and cost savings from tagging logs to the activities in the supply chain. As mentioned earlier in this presentation, 60% of New Zealand's harvest volume is exported as logs. Those logs are all measured using the Japanese Agricultural Standard, or JAS, volume measurement system. JAS is based on diameter measurement of the small end of the log. This has been raised as an issue by the stakeholders group since the tag will be placed on the large end of the log. Processing of stems into logs is carried out big end first for delimbing, value recovery and breakage minimisation reasons, so it is more efficient to place the tag on the big end. Luckily, when a saw cut is being made, the big end of one log is the small end diameter of the log that has been cut before it. There are a number of different ways that the diameters of the small end or large end, whichever way you want to look at it, can be determined, including vision-based systems, harvester head measurements, or scans when the log is delivered to a mill. Further work is planned to address the JAS measurement issue. Finally, I would like to briefly mention collaboration that has begun between New Zealand and Australia. The University of the Sunshine Coast has just started a new supply chain innovation and optimisation research program. It is funded through FWPA's current research investment plan. The focus of their program will be on new sensor systems for measuring and improving value capture, and on automated tagging and tracking of logs. I've been asked by USC to lead their project as well as the FGR project over the next 2 years. More information on New Zealand's tagging and tracking project will be put on FGR's website as it becomes available.